I bring up this right here. This is a display which is similar to what is on my Geocron, which is actually a big screen TV, and it has a little computer on it there which presents a map of the world. And one of the things on it there is this little block of information here. Now, before we really get into that, you need to know a little bit about the ionosphere there, and what the different layers and how these layers affect what your radio signal is doing. We're going to start off with the D layer there. This is the closest one to the Earth there. It's only 48 to 90 kilometers above us there. And as you notice on the chart here, it's only during the daytime hours that we have this layer. At night, this layer is not being ionized by the sunlight and the hard X-rays that you get from solar flares. So, it dissipates, and it essentially disappears there. But sometimes we have where you have what they call a polar cap absorption. This is when we get hit with a massive amount of ionization of this particular layer, and it will basically prevent radio signals from going over through the polar regions. And as I say, you can really see the effects of this layer when if you take the old AM radio there and you start listening to it, you compare what you hear during the daytime as to what you hear at nighttime. And a lot of these stations, the distant stations, are absorbed, their signals are absorbed through the D layer during the daytime there. And the D layer is not something that's turned on and off. It kind of progressively builds up to about the noontime when it's getting the maximum amount of solar radiation. And then after that, it begins to gradually go down until sunset there, and that will, the layer goes away. Then we have the E layer. This is 90 to 150 kilometers above us. So this layer is ionized by the soft X-ray rays, and it's the far ultraviolet solar radiation. The E layer reflects the radio waves that are 10 meters and below. So this is, provides you with when you're getting on to your 80 and 40 meters in the evening there, this is the layer that reflects this particular band. Now the other wave, the higher frequencies will go through this layer and will not be reflected by it there. Now we do have in this E layer there, we have what we call the sporadic E layer. These are clouds of intense ionization that can support reflection of radio waves with frequencies up to 50 megahertz and above. This is where if you get 2 meter skip coming in from distant places, this is probably the layer that is causing them. Now there are other methods that increase propagation on 2 meters and above there, such as ducting, but that's not affected by solar radiation there. And this sporadic E could cause you to have skip between 900 to 2,500 kilometers, with multiple skips up to 15,000 kilometers. So probably is possible to get a DXCC on 2 meters.
Wow.
But it's not gonna be with your FM mobile or your Baofeng handheld. Then we have the F flare. As you can see, at nighttime, we only have one F flare. During the daytime, we have, the F flare actually becomes 2. There's an F1 and an F2 layer. But, and this is the layer that is responsible for, your skywave propagation, which, will, give you your skip on, 10 and 20 meters and all that. This is your, as I say, this is the, what this is part of what you see here. Now what you really, starting off here, the date and time, you want to constantly renew this, because these readings will change. And if you don't have a current set of readings in front of you, you're going to be working under some erroneous information.
I had a question about the layers before you move on. Is it physical? Like if you went up there and with a jar and captured it, could you bring him back down?
No.
It's ionization of the layer there. Maybe you could capture some of the ions, but you're not going to be able to see them.
Yeah, a little microscope or something.
No, I don't think so.
Okay, now we're going to break down into some of the different readings here. The solar flux index. This is the amount of the solar noise measured at 2800 megahertz. And this is updated daily. Now all these different things will, some of them will be measured, just daily. Some of them will be measured, several hours a day. Some of them are only, will be measured at different time intervals. So that's why you need to get, updated information there. Now on this there, this, the solar flux index gives you an idea how the ionized F flare can support radio communications on HF, and more especially on 20 through 10 meters. Now 70 is poor, 160 is good, and 280, we could just hope, get something like that. On this particular one, which I took off of QRZ, so I could present it here. You see we have a solar flux index of 164. Now the sunspot number is a calculation which is the roughly the 10 times the number of the sunspots that are facing us, and plus the individual sunspots. The sunspot number generally kind of follows along the solar flux index. It's another indicator of how the F flare is doing. Now on this, 2 is poor, 90 is good, and 220 is fabulous. Now the A index, and that's A index planetary, is the long-term stability of the Earth's magnetic field. And this is measured and averaged out through a number of different locations across the globe there. So it's not just one place that's doing this. Now 4 is calm, 4 and below is calm, 40 you have a minor storm, and 80 is forget it. The K index is basically the same thing. It's also a planetary index which takes measurements from all over the globe. But 1 is calm, 5 you have a minor storm, and 7 is severe. So, you know, your K-index is up around 7 there, you know, it's not gonna be good. But then again, as KI4JFZ would say, you know, you don't know if something's working until you put your call out. And if you get results from your call, then, you know, go to it. The X-ray emissions, this is what ionizes that D layer that I was talking about. And the stronger the radiation, you know, the lower the ability of your radio waves to propagate, you know, by skywave propagation. And this is, you know, basically they give you, they break it down into classes, A, B, C, M, and X. This particular one, we have a C category here, and the number following that, 1.2, is it is a logarithmic reading of how, in that particular class, how well this, how these X-rays are damaging the D layer there. Now, I don't really mention the X-ray emissions during my thing there. You know, basically I will give you the, you know, the solar flux index, the Spunsat numbers, the A index, the K index, and then I'll jump down to the proton flux and electron flux. But these are other measurements which, you know, you have to take them as a whole. You just can't rely on any one particular measurement to give you, you know, the complete view. You need to take all of these numbers together.
So is C worse than A?
What's that?
Is C worse than A?
Yes, it is.
Okay.
And when you get up to X, you know, that D layer is, you know, trying to absorb everything. Now, the 304 angstroms is the relative strength of your ultraviolet, you know, how it affects these layers here. And there's several different, you know, you have the designation after the, there, you have Eve, Sola, and SEMI. These are satellites that are, you know, taking the measurements. So this one was taken with the SEMI group here, and these measurements are updated hourly. Your proton flux density is the density of the protons in the solar wind there. And the higher the value, the greater the impact on the E layer there. And that's the layer that reflects back the some of your back the 80 and 40 meter through the D layer there. The electron flux density is the density of the charged electrons in this solar wind. And it also has an effect on the E layer. Now they say that 0.10 is good, 2 is moderate, 20 is heavy. Now I've seen some of these measurements where you have, you know, it will be up in the thousands. And the electron flux density, some of these I've seen as high as 15,000. Now here we have the aurora possibility. Now the aurora is this thing that everybody wants to go up and take, you know, view up in the northern. And they have some very pretty pictures on spaceweather.com of some of the auroras. And the aurora, if you get the aurora there, that's you know, it's going to be the greater the number here. They start with you know, 0 to 10 plus. Well, that was the old scale. It's now 5 to 200. But the higher the number, the more this aurora is coming, you know, further south on the globe, and further north coming up from the other poles. The auroras start at the poles and work down through the lower latitudes there. And the B subset Z is your interplanetary magnetic field vector. And basically, if you have, you know, positive numbers, you're good. I haven't seen anything probably more than about an 8 on this number here. They're saying 20 is good, 2 is okay. Negative numbers are disruptive. And the solar wind, this is bringing all these protons and electron flux density, proton densities from the sun's surface there generally through a hole in the sun's atmosphere. And this is what causes the problems when they you know, energize these various layers.
I got a question for you, Bob. And the B subset Z, when it hits negative numbers such as you're showing there, what exactly gets disrupted? Because I'm totally new to this, so I kind of inquiring minds want to know kind of thing.
Basically, when you have that, you're having your electron flux densities and your proton flux densities are building up, and they're causing you know, the disruptions in these layers there.
Okay, so it affects propagation.
Yes, all this affects propagation there. Now, I'm no expert on this. I'm just trying to hopefully, you know, show you folks what some of these numbers mean, so you can make some informed decisions. And if you really want to know, the ARRL puts out this book here,
Oh, great.
which gives you a whole lot of greater insight into what I've been talking about. Plus, there's a lot of information on the internet. You can go to Wikipedia, and they have, you know, articles on the ionosphere, which is where I got a lot of my information. Then you have the little section there that talks about the HF bands. And the HF band panel here, you know, shows you, you know, according to the predictions, you know, the information you're giving there, how are these bands going to do? As you can see, you know, there's a day and a night, you know, like 80-40 meters there. You know, it's generally poor during the day and it's good at night. That's, you know, generally how it works. Though when you have, with your, and then you work down to your 12 to 10 meter there, and that's just the opposite there. It's good during the day and poor during the night. But then again, the true test of whether a band is you know, open there, as KC4SXO would say, you know, get on the air and put out your call.
So what is the scale on that good, fair, and poor? Is that the only three words that are appearing there ever? Or is there an excellent, you know, what's the
Generally,
scale?
they only put poor or
Poor, fair, and good?
yeah.
Okay.
The geomagnetic field is, you know, there's a number of different things. There's inactive, there's very quiet, unsettled, active, minimum storm, major storm, severe storm, and extreme storm. What you're hoping for is to find inactive, because that means the geomagnetic field is not working against you. As you go up the scale there, this is, you know, each one makes your being able to make contacts a little bit more difficult. Then they have the signal to noise ratio, and this is just, they use like in 6 meter decibel dB increments just like your S meter there, and, you know, if you, oops. And if, you know, yeah, and S0 to S1 is not bad. If you get up to, you know, a 7 or 8, you know, you're beginning to have some difficult listening conditions.
Turn on the amplifier.
And then there's the maximum usable frequency out of Boulder there. And I imagine in other places of the world, they use, they might reference their, you know, as a place that's closer to them. But there's 11 locations throughout the world where this is, where they test for these propagations. Alex?
Now, if I understand correctly, that maximum usable frequency at Boulder is they've got antennas pointed straight up and they bounce it off the ionosphere and see what comes back to them, right?
Yeah.
So if you're thinking about using that number, you're like, if I wanna talk to someone who's on the other side of there from me, I'm gonna be bouncing off of that part of the ionosphere. So not necessarily if I wanna talk to Boulder, Colorado, but if that's where the skip's gonna happen, that's what
Yeah.
matters. Okay.
Then you have your solar flare probability, and that's, you know, figured out by people who, you know, watch the sun. They have pictures that they put on spaceweather.com showing the various flares. Some of the sunspots there have very stable magnetic fields, and then you have sunspots which have magnetic fields which have, you know, you have a number of negatives and a number of positive areas, and these are generally the ones that you know, that will produce the maximum solar flares, the M class and the X class solar flares. And as I say, they have a solar flare probability of 55%, and it's, you know, when they start seeing, you know, these sunspots which have the numerous magnetic fields, then they, you know, that probability goes up. Then you have for your VHF conditions there, and this is getting back to that sporadic E. Now most of these readings are showing, you know, sporadic E in places in Europe there. You have 6 meters, 4 meters, which is the 70 megahertz band, which we don't have in the United States, and 2 meters. Now, if they say that, you know, that 2 meters is open there, or you have, you know, 2 meters sporadic E there, then some places in Europe is getting sporadic E signals bounced off, you know, from up above there. And they even have one for the United States there. And down here at the bottom, we have a little, you know, it shows you where the sporadic E clouds are in the ionosphere there in the E layer. And this, as I say, sometimes you can get some fantastic signals. I've talked to an individual here in the area, and he's, you know, talked out into the Midwest and beyond on 2 meters using sporadic E.
Wait, could you go back to that? I had a question. You know, I'm looking at that, and it typically does say band closed for 2 meters. Well, you know, it's over there, but that may be generally what's going on in the world, but what do you mean band closed, you know, because I can still
There's
go 5, 30
generally
miles.
not a whole lot of sporadic E activity in that particular, you know, in Europe.
But it doesn't mean my local 2 meter is not gonna, not gonna work, right?
No, that, generally 2 meters local there, we're line of sight.
Right.
Now, in the VHF there, you have what I think is basically three methods. You have your direct line of sight, which you know, you can get a little bit over the curve of the Earth there. Then you have your ducting, which is caused by weather. You have like a cold front overrunning a warm front, and this creates a duct which bounces these signals along. And some of these can be quite interesting. You can talk across the Gulf on them. And then there's sporadic E, which goes up into the ionosphere. And this is what this is covering here.
Is that more for sideband? Or
It probably
could be-
would be. Now, the ducting is also in,
I suppose it
is for, we'll do FM there. I witnessed ducting on TV.
does.
Back when I was down here, I was picking up
Oh, yeah.
Miami stations in my apartment in downtown St. Petersburg, you know, on rabbit ears.
Wow.
I remember reading about that, and then that's when people, hands would know, oh, go get the radio, cause there's something going on possibly.
Yeah.
Now I got a quick question. With the ducting, you said that it's affected by weather and it's basically a cold front overwarming the warm front, overrunning the warm front. Is there any specific weather phenomenon that will make that change when that situation happens? For example, like a storm like say a hurricane or a
No,
tornado
it's
or anything like that?
basically, you know, it's when you have a, you know, the cold front's coming down or a warm front coming up, you know, happening in the spring or the fall there.
I think it's an inversion layer.
Yeah.
Okay, so it's fair to say it's not affected by any
Yeah.
given weather, a certain weather phenomenon? Or a certain weather
Well,
phenomenon?
it's
Well, there's a difference.
by the fronts.
Okay, it's just the fronts, strictly.
And you're on, it's going back to the sporadic E there, generally this occurs during the, summer months, when you have the most intense, radiation hitting the atmosphere.
I had a quick question. Where do they get the data for those charts on the sporadic E? Is that based on like APRS receiving and stuff? Cause I know that's how like the VHF DX map works.
I'm not quite sure
Okay.
where they get it. I imagine they have, you know, there's a monitor someplace looking for, signals coming in on specific frequencies.
Beacons and stuff.
Yeah,
Okay.
beacons.
Thank you.
And I got one of the questions, the ducting specific to sporadic E only, or could that happen in any?
Two
It has nothing to do with sporadic.
Two different
It
things.
has
Nothing.
nothing to do with
Okay.
sporadic E. It's just another method in which your VHF signals get, more than, you know, line of sight.
Okay. Great, thank you.
Then another section of the chart, your VHF, and then they have your maximum usable frequency there. This is for, they have your Earth, Moon, Earth degradation. And this measures it, and it gives you, you know, how well the path, you know, works to the moon there. And then you have very poor, fair, and good and excellent. And this is updated every 30 minutes there. And as you can see, this one is fair, so there's very little intent.
Question
And
on the maximum usable frequency. That's a localized region that has a particular high frequency. I've seen contour maps where they have MUF, or let's say 30 megahertz here and 10 and whatever. But when you DXing, you involve many skips. So how does that work? You gotta take the lowest of the entire path, or
It's more of just an estimate.
because it could be here, it could be 30 megahertz, the maximum here, but in Australia it's something else.
well, it's because they're, you know, the sun may not be shining in Australia there, and that F flare is not being.
Correct. How do you make use of that number if it's a function of your propagation path?
Well, when you
Yeah,
look
it's
at,
in your call.
Yes.
Honestly, I mean, well, it's just an estimate, so.
These are VHF as well.
Yeah.
but also, you said it yourself, when you can run a localized, maximum usable frequency,
Yeah.
more or less certain on where you're at, and it gives you like a gradient, right? And so
Right.
what it's telling you is, I wish they would call it like
suggested maximum usable frequency. There's a little bit of art to it, right? But the idea is that you look to a given, you don't go, I want to use 30 meg and talk to Australia. You say, it looks like I have, it looks like this frequency looks good for Europe from where I'm at, so I'm going to try to talk to Europe now. So in other words, you don't bend it to your will, you sort of use it as a roadmap for where you can talk to. Right, but it also, there's also like, I mean, until 2 years ago when things started getting good, I don't think I ever once saw this agree with the frequency I was talking to somebody on, right? Because it just, the atmosphere hated us for a couple of years and the sun was sad, and I mean, we all still talk to people in foreign countries, right? So
The sun's a sad ham.
the sun is a sad hamster. Sorry, Bob.
Okay. Okay, back to the, EME, degree there. Oh. Yeah, this, as I say, is for your Earth, Moon, Earth, path there. And as I say, there's maybe times when, you you have very poor propagation or, and this right now is fair, so it's, medium attenuation there. Maximum usable frequency, this is, for VHF here. This is not, for your HF, but this is specific for, VHF. And you can, you will see here, you have a colored band, and this is the time in UTC here, and you can see there, this band down here, which, the blue is a very minimum, where the red is a very, likely that, you're going to have it. And this will, tell you when, when they're expecting you to be able to use, sporadic E there to, help, get your signal out. And then we have meteor scatter, and, that, that is there. Back to the maximum usable frequency here, you have this gray bar, and, that means it's, so. And the, meteor scatter, as I say, these are the times when they expect that you're gonna be able to use this. And you can also, well, for meteor scatter, you look to places, spaceweather.com, and they will tell you, well, we're gonna have this particular meteor storm in the area, it's gonna be affecting the Earth's atmosphere. There you will have these meteors as they burn up in the atmosphere, providing you with the ionization. And,
Usually six meters, usually? Or it can just vary?
it's 6 meters.
10 meters?
And probably that you're going to be wanting to use CW or one of these specialized digital modes.
Oh, right. I know that the moon bounce is pretty much usually CW.
Yes. And here's some of the sources that I use here. This is a website, and it gave me a lot of the definitions for these various, for the various meanings of all the things that I've been talking about there. And then you have other place, there's spaceweather.com. QRZ had where I got the little block there with all the various numbers and everything in there. Then there's NOAA has an amazing amount of space weather type stuff, and this is the dictionary which describes a lot of the terms. And Wikipedia had a real nice article on the ionosphere. And here's some of the additional reading you can do. You have your here to there, radio waves, propagation. Your ARRL operating manual has a nice section on propagation, as does the Handbook for Radio Communications. So I will attempt to ask and answer any questions that you, okay, Paul?
Would you be kind enough, if you haven't already, put this up on the SPARC resources page, your presentation?
We could give that, if I get a web address, I can pass it on to somebody there.
Yeah,
You
just
know,
send
they
it to me,
have
Bob, I'll
the
get it
whole
up there.
slideshow.
That'd be superb. Thanks.
Anything else? All right, thanks a lot, Bob.
It's been an educational experience for me. I learned how to make a PowerPoint presentation.
Good job, you're the first one.